Hello everyone, welcome back to my YouTube channel. I am Vaishnavi from Sri Venkateshwara College of Engineering, Department of CSE AI. Today in this video, I will be discussing about definitions and examples of particular groups, Kalin-4 group. Introduction to Kalin-4 group. The Kalin-4 group, denoted as V or K4, is a group with 4 elements. It is the smallest non-cyclic group and is isomorphic to direct product of two copies of a cyclic group Z2. The group is named after a German mathematician Flex Kalin. Elements of Kalin-4 group. The Kalin-4 group consists of 4 elements. Elements are E, A, B and C. The identity element is denoted as E and behaves as an identity under a group of operations. The other 3 elements squares to the identity a square equals b square equals c square equals e. Cayley table of Kalin-4 group. The Cayley table for Kalin-4 group is 4 cross 4. Table that shows the group operation results. The table reflects the closure property of the group, where every operation of 2 elements results in another element in a group. The table of Kalin-4 group is symmetric due to group being abelian. Group operation in Kalin-4 group. The group operation in Kalin-4 group is typically represented as addition module 2. The operation is commutative, meaning that the order of element in operation does not affect the result. The operation table for a Kalin-4 group shows all possible combinations of group's element. Subgroups of Kalin-4 group. The Kalin-4 group has 3 non-trivial subgroups E, A, E, B and E, C. Each of these subgroups is isomorphic to cyclic group Z2. The Kalin-4 group has no proper non-trivial subgroups other than the 3 mentioned. Isomorphism of Kalin-4 group. The Kalin-4 group is isomorphic to the direct product of Z2 and Z2, denoted as Z2 cross Z2. This isomorphic shows that the Kalin-4 group is a product of 2 cyclic groups of order 2. The isomorphism preserves the group structure and operation. Applications of Kalin-4 group. The Kalin-4 group is used in various areas of mathematics, including group theory and abstract algebra. It serves as an introductory example for studying group properties and operations. Understanding the Kalin-4 group helps in grasping more complex group structures. Example 1. Symmetric group of rectangles. The symmetric group of rectangle is isomorphic to the Kalin-4 group. The transformation that preserves the rectangle shapes forms the element of the Kalin-4 group. This example illustrates how group theory can be applied to geometric shapes, as you can see in this figure. Example 2. Coding theory. The coding theory. The Kalin-4 group can be used to analyze error detecting and error correcting codes. The group's properties helps in understanding the structure of codes and their decoding processes. Coding theorists use the Kalin-4 group to develop efficient encoding schemas. Example 3. Quantum computing. In quantum computing, the Kalin-4 group appears in a context of qubit operations. The group structures influences the design of quantum algorithms and quantum errors correction codes. Quantum computing researchers utilize the Kalin-4 group for developing quantum protocols. Representation theory of Kalin-4 group. Representation theory studies how groups can be represented as a matrices or linear transformations. The Kalin-4 group has two non-isomorphism, irreducible representation in dimension 1. This representation provides insights into the group's properties and structures. Automorphism group of Kalin-4 group. The automorphism group of Kalin-4 group is isomorphic to S3, the symmetric group of degree 3. This automorphism group consists of permutations that preserves the group structure. Understanding the automorphism shows the shades lights on the symmetries of Kalin-4 group. Homomorphism involving Kalin-4 group. Homomorphism are mapping that preserves the group structures. The homomorphism involves the Kalin-4 group can be studied to understand group morphisms. Investigating homomorphism provides insights into how the groups interact and transform. Group actions of Kalin-4 group. Group actions involve the group acting on the sets, preserving its structures. The Kalin-4 group can act on itself or other sets, leading to different permutations. Exploring group actions of Kalin-4 group reveals its symmetries and transformations. Conjugacy classes in Kalin-4 group. Conjugacy classes group elements that are related by conjugation within the group. The Kalin-4 group has one conjugacy class for each element, as each element is self-conjugate. Analyzing conjugacy classes reveals the relationship between elements in the group. Group properties of Kalin-4 group. The Kalin-4 group is a finite, Eli-blind, and non-cyclic group. It is a unique subgroup structures due to its small size and specific element relations. Studying the group properties of Kalin-4 group depends and understands of group theory concepts. Group homomorphism of Kalin-4 group. Group homomorphism or mapping that preserves the group structures and operations. The homomorphism involves the Kalin-4 group can be classified based on their properties. Investigating group homomorphism provides insights how the group interacts with other groups. Applications in cryptography. The Kalin-4 group is used in cryptography protocols for secure communications. Its properties are leveraged in encryption schemas and key exchange algorithms. Understanding the applications of Kalin-4 group in cryptography enhances the data security practices. Let us conclude. The Kalin-4 group, with its unique properties and applications, plays an significant role in mathematics and related fields. Studying the group structures and operations provides valuable insights into a group theory and algebraic structures. The versatility of a Kalin-4 group makes it fundamental concept in various mathematical disciplines. This is all about the Kalin-4 group in mathematics. Thank you.